Hello everybody. I want to show you after 1 day training what I have been learned of using this HSG tube cutting system and how the software works and how these parts can be done. So these parts are some very characteristic of regular daily use of the joints, or how we gonna take use of this laser cutting tube laser machine, how to achieve these things. So let's start. First one I want to introduce is this basic one. This is a two piece of 2-inch around stainless steel tube. As we can see, to finish this seamless finish of the joint, we did design this cutting with a space for this finish. So this is a very basic operation. You don't need a bevel cutter or anything. You can have a perfect joint like that. So after that you can weld and a lot more joint. If as long as you can design, you can apply for your requirement. So this is the basic. You just cut as when the laser cutting, it's gonna go like straight, and the cutting head doesn't move, and it moves left as it rotates, and then moves back, and then go again and finish. So you can see it's very clean. No fur or slag or burn, anything. Usually to have this color finish, use nitrogen. And the second one is a little bit trick. So at the design, it cuts a hole on two pieces, and throughout it's very precise. And this is the finish. At the joint, what we've been using is we use a function from the nesting software called weld finish makeup or weld curve. So supposedly, as this design from the SolidWorks, you will have a straight finish. So this straight line will go very tipped, pointed, and join this two. They're gonna join together at a very sharp point. But here, what we've been doing is we kind of cut off that tipped point. What is it for? Is when we do the two piece with the weld curve, we can have a better joint at the end. So the stick out finish won't go against with each other, so you can have easy and more beautiful finish. This hole here, this gap here, you can see it's a little bit curved. It's because this material has tension and this material is not perfect. So the cutting head sensors, it's deformed and it goes all the way same distance from the surface and how that finish. And you will notice that we will have a tiny little like stick out finish here. This is called a lead line spot. So every cutting, every two path cutting is gonna start from somewhere, give you a lead line to this point, and then start to cut and turn at the sharp corner. You can see it's kind of clean here. And also this is a design joint. So when we put this two pieces together, it won't move back and forth. So the welder it's gonna be easier for the welder to weld them together. And that's what it is for. So you can see the joint is very clean and neat. So this part shows the weld curve. And also the third one, it can't wait for its showtime already just fall. So as we can tell, the function can be adjusted, the power can be adjusted to not cut through and to generate this marking. And this marking is not perfect. It's my practice time. So I didn't spend quite long minutes to adjust the parameter, give it a clean and beautiful marking line. It's just to show. And some parameters I didn't adjust it to the very end perfect. But what they want to show is for all these holes, usually if you're cutting a hole, the laser cutting head is gonna be here, and when it cuts, the tube rotates the same time. But this function here, we lock the axis, it doesn't rotate, and I use my cutting head to wash a hole here without any, this inclined finish. It's all straight. So if you want to put a straight stick or something, you can put all the way in without anything in the middle, in the way it goes. And here for the finish, also we're using the same thing called weld. It's called weld curve to avoid the stick out shape. So originally this cutting line would look like more curved and more finished and all the way until the finish. But here we just cut through earlier, so we cut off a little bit tip or the bead. Then it leaves more space if we want a T-joint. This T-joint would work like that. So you're gonna have a minimized same gap here, as we can see. Also, for example, if we're gonna cut this single piece as a slot, we can put a piece of cardboard, advertisement or commercial flyer or something in the hole and go through. This is why we use this function. Also, we locked the rotation line to have a straight, all the way straight throughout this cutting slot. That way, you can control on the nesting system or parameter setting. Then you can have something like that. So you'll notice this one is one more part cutted compared to this. Then it's designed for a 3-pipe connection, like that, straight and clean, as you can see here. And again, for more parts like that, if we only want one part to be bent as a beautiful finish, this is what it's gonna look like. And you will have, we need some tooling to bend them neatly, form a basically seamless joint, like that. The finish will look like that because it has tension inside of this material. Excuse me. Sometimes what we can do, we design some slot to counterpart this bend out. For example, like that. See how clean this can be. And the finish would look more beautiful, more clean and beautiful, like that. Very straight. And the size can be set through the software. Then you can put like that. And when you bend, it bends neatly. You barely see the light leak out. See? how beautiful it finish. And for the slot, if you are cutting a long slot, it has the function you can have minor joint in the middle, something like that. Then you will have some part of leftover material holding these two pieces before it breaks or before it split. That's how it will work. And also the last piece, you can see I just cut off or bend it off. It's fatigue. So otherwise it's gonna form a very beautiful square. So this is it for now. Hope you like this video.